So in previous videos, I showed you how to train a simple linear regression model, both by using Visual Studio's ML.NET Model Builder and by using Visual Studio Code. For that, we need to load the data, inspect the data, transform the data in case of invalid values, fit the data onto the model, test the model, and evaluate the model. We draw our conclusions and do it all over again to improve the model training. In these videos, we achieved accuracy scores of about 60%. That's of course not at all what we would want. So we can keep repeating this process to improve the model until we get about 80 or 90% accuracy. So definitely try that yourself, tinker with the notebooks. Those can be found on my Kisco.com website by becoming a member, or on my Patreon, the same thing. Check out my products and like and subscribe. I want to dedicate this video on inspecting the data visually, because we skipped over that a bit too quickly in previous videos. To give you an idea of what I want to achieve, I'm going to go to the Kaggle.com website, or however you pronounce that, and we'll just take a look at a Python example. So the first thing you see here is load the taxi fare data. Then he continues inspecting the training data set by just visualizing 5 of the first records. The same for the test data set. So if you remember the 80-20 split. Looks quite similar, which is a good sign. If you don't shuffle the data set and then you do an 80-20 split, it could be that the test set only contains the last 20 values, which could be the 20 maximum values. And if you hide that from the model, then train it on the training data and then try to predict a value that would lie somewhere in the top 20, the maximum 20 values, then the model may not perform on that too well. So that's why it's important to shuffle. One of the reasons why it's important to shuffle the data. And then this is a very interesting one, the train dataset.describe. Then it generates a table with percentiles, 25%, 50%, 75% maximum, minimum, standard deviation, the mean, and the total count of rows per column. Why this is important is because in here you can, for example, see if you can already spot outliers, values that are way outside of the expected range. If you see here the percentiles, the 25th percentile minus 73, then the median, so the middle one, is about the same value. Then the 75th is more at the end of the data set, is still looking quite similar. But then the maximum, and well, the minimum is also closer to all of these. The maximum suddenly jumps to positive 40, which is quite a big leap between the 75, which should be closer to the max. So in between the 75th and the max, there may be big gaps or jumps in the data. He writes some conclusions for every step. So he writes about an outlier, the pickup datetime column of value 43. Here you can see the invalid values. Then he also does describes on specific columns, which is a fair amount. Here the maximum is 453, while the rest is basically between 1 and 12. So the data is a bit skewed there as well. And I think he concludes that the fair price of 400 plus is not possible. Some more conclusions. Spotting some outliers which he wants to drop. Then he starts plotting a bit, visualizing the data. Basically, let's see. So the amount of rides, and then how many grouped by passenger count. So there were 2,000 rides with 2 passengers, most were with 1. Some rides were with 3, 4, 5, 6, and so on. Single traveling passengers are the most frequent, yeah. The highest fare prices are coming from the single and the double traveling passengers, which maybe because they go the furthest or something like that. Let's see. He's trying to display, to plot the relationships between different features. So between the date and the fare. Don't think there's much exceptional here. Then between the hour, so basically when the most rides are happening at which hours, that's pretty interesting to see, I think. Observations, lowest caps at 5 a.m., highest around 7 p.m. It's the rush hours. Relationship between time and fare. When the costliest prices are. Then impact of the day of the week and the cab rides, which seems to, yeah, Monday, Tuesday, or is this Sunday? I can't tell. But it doesn't vary too much, so the days of the week does not seem to have much influence on the cab rides, and so on. Let's see, between day and fare, Sunday, Monday, Thursday. Relationships between distance and fare price. So the further you go, the higher the price, likely. The distance, and here, the price up. So this is long distance and more expensive than most of these. However, these seem to be very far, but not that expensive. So he says there's an obvious relationship between the distance and the fare price. Anyway, feel free to go through these notebooks. What I find interesting in this is he's trying to find the relationship between different features. So what, likely looking for linear relationships. If the distance goes up, the fare price goes up, and insights like that. So I'm gonna try a similar thing. For simplicity's sake, I'm just gonna do it on my own tiny data set and not on this taxi fare data set. But do, if you have access to my notebooks, do try that for yourself on the taxi fare data. To make these plots in C#.NET inside my polyglot notebooks, I will be using ScottPlot, which you can use in the .NET notebooks, but also in Blazor, in your .NET Core APIs. Okay, start by install. So the quick start in the polyglot notebook, we install the NuGet package, NuGet ScottPlot, version 5. Our Microsoft machine learning package, as you've seen in previous videos. Now I've added matnet.numerics to have easy access to mathematical methods like correlation to get the median or calculate the mean and so on. But regarding the ScottPlot, we'll have to use this for notebook usage, which is basically going to allow us to display our plots as a base64 image PNG. Right, yeah. I've run everything. Don't forget to use the ML data. Then this is similar as the last video, just mapping my CSV data. We've got a few columns, and I was most interested in animal page visits in the relation with promote button clicked. So I tried to predict, based on the page visits, the amount of promote button clicks, or vice versa. So model input, model output. This is not too important for this video, but do watch the previous video to understand all of this. We're simply loading my tiny dataset. Do try this with the TaxiFair dataset, which you can just find in the TaxiFair example notebook. We're loading the data. I added another package which allows us to access this description method. So basically, NuGet Microsoft Data Analysis, and we're transforming our data view to a data frame, which is DataFrame implements the data view, but we can do much more on the data frame. I'm just going to use it for display at this time. So I can use a similar function as we had to describe in Python, this description in here, although I am missing the 25th, 50th, and the 75th percentiles, but you could calculate them, which would be interesting to see, well, to spot outliers and so on. So now we've got the min max on animal page visits, 148, max 615, and the mean, which is the average, at about 335. Amount of rows, just 12. It's a tiny data set. And for the other values, we have similar things. You do have some null values as the min, which is possible. You can see the first 5 records. Rows are just doing df head and then add the 5, otherwise it's like 10 or 100. And tail is the last records of the dataset. df.info is just, yeah, more about the types of columns, data types. A sample is a random sample of the dataset. df.columns, which is a bit more visually pleasant than we tried on the data view.columns or .row view. It's just, so this is the column of the animal page visits, all of its values. And the other columns below. We could go to the cookbook and see how to customize everything, but then also the plot types, which I'm trying to look for now. So the heat map is a cool one. The bar plot, the histogram, if we can find it. Then you've got this signal plot for a lot of data points. It's more performant on a lot of data points. Then the scatter plot, and you've got the radar plot, population plot, and more. So again, the quick start, you could have, like I said, 2 variables for the x-axis and the y-axis, and then just add those, or you could use those coordinates like here. You could also use floats, but yeah. And so on. Okay, and lists. Could only have the lines. Could also only have the points. Then you use the scatter points. It's going to be interesting for our linear regression. Signal plot is a bit similar, but for extremely large data sets. The bar plot. So to visualize those amount of rides and the passenger count, basically grouped by passenger count. There's also a histogram, but I can't see it. Histogram, which is a bit similar. Number of people, height in centimeters. So there's 350 people in between 170 and 180, 175 likely, something like that. So I'm using these coordinates simply because I can then make a pair of the x and the y values and then order them all together by ascending instead of risking to order the x and then the y differently. That's not a good idea. Anyway, the plot, and then the scatter points at the coordinates, and then I added this simply to try to draw a straight line from the minimum to the maximum, basically going through our data points, well, hopefully. Just setting the titles on the x and the y axis. Then a similar function for the histogram, which maybe I should have used a bar plot. Anyhow, so features, the animal page visit, labels, the promote button clicks. And I'm constructing the scatter plot, features, labels, title, and title Y. Okay, and then we see this line is basically from the min to the max, and our data points. So for 150 animal page visits, we've got about 15, 16 promote button clicks. And it's just to illustrate, try to visualize the linearity in our data. So is there an easy linear regression model to train? Not a well, likely a more complex one can map the values better, describe the values better. We see some gaps here that could cause a problem if we want to predict values that are around these zones, which wouldn't be too great. Then again, just have a mini data set. You want to have you can also see the data balance. Let's say all the data points are at the beginning. It might be harder to make predictions at the end. So you'll want to spot all those data inconsistencies and act accordingly. Then I'm preparing to map, to plot the features against each other and to spot linear relationships between the features. So these are the features, including shared click, contact clicked. So we could assume if there's more animal page visits, there could be more contact clicks, more share clicks. We kind of assume a linear relationship in there between those. Between button clicked and transaction created, there should be also one. The more of these, the more of these. I'm just displaying the values again. You can use this display. This is basically a bit like a console.write line of the values. The first column values are the animal page visits, then share clicked or contact clicked, and so on. Then I'm looping over all of the column values. So basically want to draw plots, scatter plots for each feature against each other, but when it's about the same feature, so animal page visits, I'm just gonna draw a histogram or a bar plot. It's not always gonna make sense to do this, but let's have a look. So you can interpret this as basically grouping the data points. This y-axis is also animal page visits, but it's more like grouped. So we've got 3 records with animal page visit value of around this 200 and so on. Then the relationship, we're gonna try to plot against share clicked and animal page visits. So assuming the more animal page visits, the more share clicks. And we do see that. We do see the linearity here, although there's a few, and then there's a few other points, and then we have these null values that maybe we'll want to filter out. Let's see, 3 records with about 7 or 8 contact clicks. Okay, promote button clicked, contact clicked. Trying to look for the linearity, seems pretty good with a few values on the lower end here, and so on. So we could try to train a model that, based on the promote button clicks, tries to predict the contact clicks or vice versa. Okay, we're going through mapping all the features against each other. What I'm doing then is, let's see, can also use the linear regression method from this ScottPlot package. It's better to train a model instead of just using these visualization methods. Anyhow, then I briefly touched on it, but the correlation matrix, that's sometimes what you'll see in the Python notebooks as well. It's basically trying to figure out the relationship between 2 features. So for that, I'm using numerics, dotnet numeric statistics to get the feature, to calculate the feature correlation. I just want a bigger display, so I did it like this. Maybe you can simply do that on the plot as well. Specify the width and height. I'm looping over these values again, but this time I'm calculating a correlation between the x values and the y values, which are basically just one feature and the other feature. So we're making pairs of animal, well, the feature values, and calculate the correlation, the Pearson correlation. You can dive into this method. Let's see, computes correlation coefficient. And then we add this to a multi-dimensional array. Then to visualize it as a correlation matrix, I'm using the Heatmap of ScottPlot. Add those correlation points on there. We log those out, so the correlation between animal page visits and animal page visits is 1, obviously. Then animal page visits share clicked is 0. Well, about 60. Animal page visit contact clicked seems about 90. That's pretty good. And so on. So we're going to have each feature against the other features. So animal page visits 1 on, of course, animal page visits, which is below. So all the features on the y-axis and all the features on the x-axis, and then the correlation value mapped in between. I had to use that y label invert to make sure that instead of animal page visits being here at the bottom at 0, 0, it should start at the top to get this nice diagonal line, which is basically the feature against the same feature. So share clicked, contact clicked, promote button clicked, promote transaction created, promote transaction created. And then all the values on this side are basically the same as all the values on the other side. This is basically just the inverse. So in here we can then spot the feature correlations. So features that are highly correlated with each other should get a value close to 1. And a feature that are not correlated to each other should be closer to 0. We've got promote transaction created and share clicked. Yeah, the only relation between these two features is that it's on the triggered on the same page, so the animal page visit. Let's see, so the more animal page visits, the more likely we're going to get promote transaction creations, even more promote button clicks, and even more contact clicks, because that's often the reason to click to go to an animal detail page is to adopt them, to share them potentially, but yeah. And that's how you interpret these correlations. Again, on a very small data set with a few data points. Do try all of this on the taxi fare prediction dataset. So to conclude this video is by visualizing the dataset, you cannot not only spot data inconsistencies like invalid values, missing values, a data imbalance. Let's say there's too many data points at the start and almost none at the end, the maximum. Or you could detect the outliers and then you can filter those out. Some filter rows by column, specifying a lower bound and upper bound, and that way you could do that. Later on in the data transformations, you could replace missing values, invalid values, and more, as you've seen in previous videos. For the next chapter about classification, we'll likely be visualizing the data more using bar plots or histograms, because we'll want to see how many data points are there for class dog, for example, and how many are cats. And in that way, we'll see, well, is there a data imbalance? If there is a data imbalance, then it's going to be more likely that the model predicts. If there's an overrepresentation of cats, then it's more likely that the model is going to predict cat. Okay, so I'll be publishing to Patreon this notebook on the members section, and check out my product. Like, subscribe if this was valuable. We now can basically have less of an excuse not to use C#.net instead of Python, since we can be plotting and describing the data similarly like the guys in Python can do.